We will discuss about different designs and data analysis. It is very difficult to discuss about all research designs or all experimental designs in the limited duration of time, but I will discuss about three main designs which are in practice. Same study, same type of research may be conducted by different designs and by the application of different statistical tools. We, as a researcher, as an investigator, we have to decide which design is the most appropriate design and which statistical technique is the most appropriate technique that suits our study. I divided my presentation into different parts. First, I will discuss about the basic principle. Partially, we have discussed about this principle. This principle belongs to the experimental studies. Next one is I will discuss about early experimentations. We have evidences of experiments from 1872 onwards, and now after that, in the third part, I will discuss about the main part of my presentation, that is designs and appropriate statistical tools. So let's start with basic principle. Let's discuss with a hypothetical example. On which principle these design works. The hypothetical title is in front of you, effect of X on Y. Here, investigators' interest is to find out the change in Y due to X. We know that in this title, X is independent variable known as treatment. Yesterday we have discussed about that. And Y is dependent variable. Here, in this example, investigators' interest is to find out the change in Y only due to X. But ladies and gentlemen, that never happens. Change in Y depends on other factors also. Interest of the investigator is to find out the change in Y only due to X. And other factors may be due to daily routine, maybe due to food habits, maybe due to lifestyle, and maybe due to heredity. One main point we have to keep in our mind that change in Y, in this example, change in Y only due to X is known as treatment variance, change due to treatment. And change in Y other than, that is not investigator's interest. Change in Y other than X is known as error variance. So we have to select a design, a research design or experimental design in such a way that fulfills the principle of maximization of treatment variance and minimization of error variance. From this sentence, it is clear that error variance cannot be eliminated. An investigator may try his or her level best to minimize the error variance. Due to this reason, there is a concept of the level of significance. In science subjects, you conduct your studies at 0.01 level of significance, and so on. So I will discuss about three main designs, three basic designs, and you will decide which design is best suited design. In this next part, we will discuss about the early experimentation. These are the earliest assumptions of the experimental research. This concept was given by John Stuart Mill in the year 1872, and this is known as a law of single variable. What do you mean by law of single variable? You should have an idea about that. In the words of John Stuart Mill, if two situations are alike in all respect, if one element is added to one, not to another, or if one element is subtracted from one, not from another, if the difference exists between these two elements, that is due to added element or subtracted element. For example, as per law, if two situations are, suppose you want to conduct a study on the title effect of morning walk on blood pressure. You want to conduct a study on the title effect of morning walk on blood pressure. So As per this law, if two situations are alike in all respect, suppose if two groups are alike in all respect, one is experimental group, another is control group. If both the groups are equal, if one element is added to one, not to another, if the morning walk is given to experimental group, not to control group, if the difference exists between two, if the difference exists between the experimental and control group, that is due to added element, and in our example, added element is morning walk. So due to in the year 1872, as per the law of a single variable, the concept given by John Stuart Mill, due to this law, there is a concept of we use control group due to this law. So on the basis of this law, if we conduct an study by taking control group, or on the basis of this law, we can maximize the treatment variance and we can minimize the error variance. Now the main story starts. Designs and appropriate statistical tools. I will discuss about only 3 designs with hypothetical titles and examples. You will decide at the completion of my lecture which design is the most suitable design. Ladies and gentlemen, please keep in your mind that our title will be effect of morning walk on blood pressure. We will discuss on the basis of this hypothetical title. In this hypothetical title, independent variable is morning walk and dependent variable is blood pressure. And this study, effect of morning walk on blood pressure, this can be conducted by using this design also. This design means single group design also. How we conduct? What do you mean by this design? We take O1. O means observation. Here O1 means observation 1 means pretest. First we will take pretest, observation 1. After pretest, X means treatment. Then the treatment will be given to all. Suppose you conducted the study on 30 subjects. You will take the observation 1 of 30 subjects. Then X will be given, treatment will be given, morning walk will be given. And after the completion of 1 month morning walk, you will take final test, that is O2, in the form of a post test. Here we have only one group. We take observation 1 and observation 2, pre-test and post test, and in between treatment is given. We have discussed this yesterday also, but we will compare this with other designs. In this design, if we conduct any study by using single group design, we have to apply dependent t-test. Yesterday we have discussed. But one more statistical technique is in front of you, that is Wilcoxon matched pair test, or we can say that Wilcoxon test. Either we have to apply dependent t-test or we have to apply Wilcoxon matched pair test. Then the question arises, when to apply dependent t-test and when to apply Wilcoxon matched pair test. If the data is normally distributed, in that case we have to apply dependent t-test, and if the data is non-normally distributed, in that case we have to apply Wilcoxon test, or we can say that Wilcoxon matched paired signed rank test. The complete name is Wilcoxon matched paired signed rank test. But we have discussed about the principle. We have to follow a principle, maximization of treatment variance and minimization of error variance. Is this design fulfills that principle? No. So this design comes under the category of ill design, simple design. It's not accurate design. We cannot minimize the error variance if we conduct our study by using this design after the application of dependent t-test or Wilcoxon test. So if any investigator want to publish his or her articles in the reputed journals indexed in Scopus, indexed in Web of Science, indexed in PubMed, so if you conduct on the basis of this design, they will not allow you to publish. There will be least chances of publication. Same study, effect of morning walk on blood pressure, may be conducted by using this design also, repeated measure design. Repeated measure design. So what do you mean by repeated measure design? In this, same as previous one, We have O1. O1 means observation 1. Observation 1 means pre-test. Then the X is given, treatment is given, morning walk is given. O2, observation 2. Observation 2 means here. Observation 2 means mid-test. Then again treatment is given. We will continue the treatment. Again, the final test will be taken. That is ON. In this hypothetical example, in this design, I have taken only 3 observations: observation 1, observation 2, and observation 3. But the observations may be of n numbers. So instead of only 2 observations, here we have more than 2 observations in the form of a pre-test, mid-1, mid-2, mid-3, mid-4, mid-5, mid-6, and final test. We can have, it means simultaneously with, in the previous one, in the single group design, the objective was to find out the effect of morning walk on blood pressure. Here, there will be slight modification. Here, the objective will be to find out the effect as well as to find out the trend of the effect. Where this increases in between, where this decreases in management studies, business studies, economic studies, biomedical researches, you will find this design is used. So we can find out the trend. In single group design, where we were having the only 2 observations, observation 1 and 2, in that we used dependent t-test or Wilcoxon test. In this, we have to use the technique repeated measure ANOVA. I will demonstrate with hypothetical data. And another name of repeated measure analysis of variance, repeated measure ANOVA, is trend analysis with one standard condition. We have to use this technique. This technique will be used in case of the data, normal data. If the data is non-normal in nature, then what will you do? Ladies and gentlemen, there is no parallel non-parametric technique of this repeated measure ANOVA. Then what we will do if the data is non-normal? What will do? In that case, we will make pairs. We will make pairs, I mean observation 1 versus 2, observation 1 versus 3, observation 2 versus 3. And by making the pairs, we will apply the parallel non-parametric technique of dependent t-test, that is known as Wilcoxon test. So we have discussed about this. Next one is, please take care. In this, we can take more than 3 observations, 4 observations, 5 observations. Next one is the random group design. Ladies and gentlemen, this design is the most suitable design to conduct any experiment. If you want to publish your articles in the reputed and refereed journals of the world, we should conduct our studies by this design, random group design. So I will discuss about the structure of the design later, but this design is also known by the name of pre-test, post-test control group design. Pre-test, post-test control group design. So the title will be same. Since we are discussing about the same title, effect of morning walk on blood pressure, the same study can be conducted by using single group design, same study can be conducted by using repeated measure design, and same study may also be conducted by using random group design, and that is the most appropriate design to conduct any experiment. See the structure. So in the first 2 designs, in single group designs and in repeated measure designs, we were having only one group, single group. Only there was a difference of the observations. But in this, instead of only one group, we have 2 groups, experimental group and control group. First, we take observation 1 and observation 3. Observation 1 means pre-test of the experimental group, and observation 3 means pre-test of the control group. And after taking pre-test, after taking these 2 observations, X is given to experimental group and no treatment is given to control group. And in our example, treatment is morning walk. And after the completion of the treatment period, suppose for after 1 month, the final test in the form of observation 2 and 4 will be taken. O2 means post-test of experimental group, and O4 means post-test of control group. This design fulfills the principle of maximization of treatment variance and minimization of error variance. How? If two situations are alike in all respect, it means experimental group and control group are same. It means O1 and O3 at initial level, if both are same, if one element is added to one, if X is given to one, not to another, and if there is difference exists in between O2 and O4, that is 100% due to added element. This is based on the law of a single variable. The concept was given by Jones to Art in the year 1872. Your cooperation is. I request any participant to unmute your mic. I will discuss something to clarify one point. Gentlemen, who will cooperate me?
Sir.
Yes. Madam, O1 means pre-test of experimental. Is it clear?
Yes, sir.
O3 means?
Pre-test of control group.
Yes. Initially, O1 and O3, these should be equal or unequal? Is it
Unequal?
Unequal. Madam,
Yes,
we have discussed in the law of single variable. If two situations are alike in all respect, these should be equal. Is it okay?
Yes, sir.
Suppose madam, you tried your level best. As per the random assignment, you distributed all the subjects randomly, but difference exists. Initially, both are not equal. It means, what you will say in that condition? You will say your assignment, initial assignment, distribution in the distribution group, there is a biasness, maybe unintentional biasness. Agree?
Yes, sir.
So, madam, this will affect the study or this will not affect the study?
Sir, it will affect the statistics.
This will affect the study in a negative way or in a positive way?
Sir, this depends on the value of difference.
This difference will, if you have you said this difference between O1 and O3 will affect your study, and you said this will affect in a negative way or in a positive way?
Sir, in negative way.
Yes, in a negative way. It means this difference will distort your study, the whole study. Agree?
Agreed, sir.
Yes. So, suppose if the initial level is unequal, then if there is a difference between O1 and O3, then what will you do? Will you proceed further or any other action will be taken by you?
Will minimize the difference.
How you will minimize? It means you will manipulate. No. One option is again by the lottery system you will divide randomly. Again same difference exists, and you tried 8 times, and 8 times difference is there. What you will do? We require a solution. The solution is given by a technique. The technique is known as ANCOVA, analysis of covariance. This, by the help of this technique, by the help of analysis of covariance, by eliminating the negative effect that is due to the difference between O and O3, this technique is by the help of this technique we find the real effect. Is it okay?
Yes, sir.
That error may be eliminated. It means this ANCOVA, analysis of covariance, is a best suitable technique to conduct any experiment if we are using random group design, or we can say that we are using pre-test, post-test control group design. So any investigator, if he or she want to conduct experimental study, which design should be used?
ANCOVA. Random group design.
Which statistical tool should be applied?
ANCOVA.
ANCOVA. So it's clear. Now I will demonstrate every design. Let's start with the first. Madam, what is our hypothetical title? Today's hypothetical title?
The effect of morning walk on blood pressure.
Yes. On how many subjects you conducted your study? Suppose 10, 20. On how many subjects you conducted the study?
15.
15. Okay. You conducted your studies on 15. And what will be your first step? You will take pre-test. Is it okay?
Yes, sir.
I am entering the scores of pre-test. I am entering these scores of the blood pressure of pre-test. Madam, you collected pre-test. After that, what you will do?
Sir, will provide
Treatment.
treatment.
Please note, we are discussing about the first design only. Single group design. We will discuss one by one. First, we will do the same by using single group design. We will do the same by using repeated measure design. We will do the same by using random group design. So what you will do, you will give treatment after 1 month treatment. Then
Post test.
post test. I am taking this. I am entering the data of post test. Which statistical tool will be used?
Sir, either dependent t-test or Wilcoxon match
Okay.
pair.
We will discuss about both. See, go to variable view. In the first column, we have pre-test, and in the second column we have post test. Now, first, yesterday we have discussed. First, we have to test the normality. Suppose data is normal, we have to apply dependent t-test. Agree?
Agreed, sir.
Yes. Go to analyze, go to compare means, go to paired sample t-test, make a pair, click on OK, result will be in front of you. Madam, what is the mean value of pre-test?
86.8002.
And what is the mean value of post-test?
71.533.
And what is the t-value?
5.578.
Is it significant? Yes. It's less than 0.01 also. Is it okay?
Yes, sir.
It means there is a significant difference between the pre-test and post-test score. Then see the mean value. It means the blood pressure decreases after the morning walk. It means morning walk is by the help of morning walk, or morning walk can be considered as a treatment for blood pressure. Is it okay?
Yes, sir.
We have analyzed by using. Why we analyzed by using this dependent t-test? Since data were
Normalized.
suppose the data are non-normal, in that case, which technique will be applied?
Sir, Wilcoxon match pair test.
Yes, Wilcoxon. Go to analyze. You may write down the commands. Go to analyze. Go to now. Where is my cursor?
Non-parametric tests.
Non-parametric. Now
Legacy dialogues.
and now.
Two related samples.
Yes, two related samples are there. Click on this. Same as that. Make a pair. Click on OK. The results will be in front of you. See the value of Z value of this. This is also significant. This is also significant. This also shows that yes, there is a significant difference between the mean ranks of pre and post. Is it okay?
Yes, sir.
Now I will proceed to the next design. What is the name of the next design?
Repeated measure design.
How many observations we are having?
Sir, two observations.
No, not at all.
Sir,
In,
more
in,
than
in
two
total group design, we have two observations. In repeated measure design, we have more than two observations. For example, observation pre-test, mid one, mid two, and so on. Is it okay?
Yes, sir.
Now you have, madam, you have to decide how many observations will be taken, how many observations you will take in your study. Decide at your own.
Sir, 10.
10, that will be
Sir, 3.
3, more than 3. 3 are minimum.
5.
5, okay, 5. It is a medium type observations, 5 observations in the form of pre-test, mid 1,
Yes.
mid 2, mid 3, and final. Is it okay?
Yes, sir.
I am entering the score of this. On same 15 subjects, you conducted the study. These are the score of
Pre-test 1.
pre-test. Pre-test means that is 1, pre means 1.
Yes, sir.
Now, in the second column, mid 1. Write down mid 1. Next is I am entering the score of mid 2. Mid 2 means third observation.
Yes, sir.
Mid 2. Again, data view. Fourth observation is mid 3. These are the scores of mid 3. Now I am going to take the final test. Final test means post test. Final test. Is it okay?
Yes, sir.
Madam, what is your objective to conduct this study? You have two objectives. Please keep in your mind. First objective is to find out the effect of morning walk on blood pressure. Is it okay?
Yes, sir.
Second objective is to find out the trend of the effect of morning walk on blood pressure. When this increases, when decreases. Is it okay?
Yes, sir.
You can find out the effect as well as trend of the effect. Now, okay. Data entry is complete. Which statistical tool will be used?
Sir,
Repeated measure analysis of variance.
ANCOVA.
Not ANCOVA, ANOVA.
ANOVA.
Repeated measure ANOVA, repeated measure analysis of variance. Another name is trend analysis with one standard condition. See, go to analyze, click on analyze, click on journal linear model, click on this repeated measures, click. Here the factor means observations. Madam, how many observations we are having?
5.
5. So instead of factor, you may write observations. Oh. And number of levels means observation. Number of observations are, write down 5.
5.
Click on add and define. Madam, 1 means
Sir, pre-test.
bring, yes. 2 means made 2, 3 made 3, and final. Is it okay?
Yes, sir.
We have the options. I will discuss later about the options. Uh, Essentially include estimate of effect size and descriptive statistics also. I will tell you why. And plots, you may enter the plots also. See, madam, how many objectives you are having?
So, two objectives.
See the value. You are, where is my cursor?
Uh, Observations.
How many observations you are having? 5.
4.
5, madam, 5.
5.
Pre,
Yes,
mid
sir.
1, mid 2, mid 3, and final. 5 observations. Your objective is to find out the difference between 5 different observations. Is it okay?
Yes, sir.
And you will decide on the basis of this F value. F value is,
0.789.
it is not significant. It means there is no effect of morning walk on blood pressure. There is no effect, there is no trend of the effect of morning walk on blood pressure. Is it okay?
Yes, sir.
If insignificant difference exists, the study ends. But if the significant difference is there, in that case, you will find out the trend of the effect. Is it okay?
Yes, sir.
Trend means the difference between observation, difference between pre and mid 1, difference between mid 1 and mid 2, and so on. Madam, the change, please note these points. These are specific statistics terminologies. The change between first to second observation is known as linear trend. Linear means the change from first to second. In our example, the change from pre to mid 1. Is it okay?
Yes, sir.
And from second observation to third is known as quadratic trend. See this quadratic trend, quadratic. And from third to fourth, that's known as cubic. Only these are 3 specific names. Except these, order 4, order 5, order 6, order 7, and so on. Up to 3, we have specific names. If the significant difference exists, you will find out the linear trend, then quadratic trend, then cubic trend, then fourth order trend. In this, how many trends will be there?
4 trends.
How many?
4.
Yes, 4 trend. Means linear trend, insignificant, quadratic, insignificant, cubic. Since overall trend is insignificant, so all these trends are insignificant. Is it okay?
Yes, sir.
So we have discussed about, and this is the this seems, yes, this improves, but this is not significant improvement. Is it okay? This is the
Yes, sir.
comparative analysis of all 4 observations: pre, mid 1, mid 2, mid 3, and final. So we have discussed about
Repeated measures.
repeated. Uh, if I ask a question from you, we have discussed about 2 design, single group design and repeat measure design. Which design is best among these 2?
Repeated measure design.
Yes, that single group design comes under the category of simple design. This design comes under the category quasi design. This design is of medium standard. Is it okay?
Yes, sir.
Now we will discuss about the design that is full of statistical control, random group design. We will discuss about that. See, madam, how many groups we have in this?
Sir, 2 groups.
2 groups. Suppose, see the data. I already have made the data. See, what is this? I don't know. Yes. Madam, see, is it clear? The data is clear or not?
Yes, sir, it is clear.
How many groups we are having?
Sir, two groups.
First group is,
Experimental group,
second group is,
control group.
and how many observations we are having? 4?
15 observations.
No, 15 scores. 15 scores. 15 is the number. It's not 15. Observation, 4 observations. Pre of experimental, post of experimental, pre of control, post of control. Is it okay?
Yes, sir.
On how many subjects you conducted this study? See, please calculate. On how many subjects you conducted this study?
Sir, 15.
On 30, madam, 30. See, you are having you have 15 subjects for experimental and 15 subjects of control. It's clear.
Yes.
Is it okay?
Yes, sir.
It means first you collect pre-test of the 15 subjects of experimental group. You will collect the pre-test of the control group. Is it okay?
Yes, sir.
And how many scores are there? 60.
Okay, yes, sir. 60 scores.
60 scores. It means you will take 2 observations of the same subject in the form of a pre and post. Is it clear?
Clear, sir.
Clear. Now, how to enter the data in SPSS? After that, my discussion will end. How to enter data? I am copying these pre-test scores of the experimental group. We have to paste in one column. All pre-test scores will be entered in single column. Sorry. Now I am copying the pre-test scores of madam. How many pre-test scores are there?
30.
First 50 belongs to
Experimental group.
yes. Next 15 belongs to okay. Now we will do the same. In the next column, we will paste the scores of post-test. 15 are of experimental group and 15 are of control group. Now write down in this pre-test is there. In second column, post-test is there. Again, go back to data view. Madam, you will agree with my statement. The first 15 scores of both pre and post belongs to experimental group. Is it okay?
Yes, sir.
Yani, write down in front of both the columns. One stands for experimental
group.
and 2 stands for
Control group.
control group. Is it okay? In the first column, we are having the score of pre, in the second column for post, and in the third column, groups. And go to values in front of groups and give this value 1 to 1 means
Experimental group.
write down experimental group. Add 2 means control group. Add, is it okay?
Yes, sir.
Okay. Data entry is complete. Now we have to analyze. Go to analyze, go to journal linear model, go to univariate. Madam, we have discussed about the elimination of negative effect. Which type we were discussing about? Which type of negative effect? The effect due to difference between pre of both. Is it okay?
Yes, sir.
That will be considered as covariate. So this
Okay.
bring this pre in the covariate.
Mhm.
We will eliminate this effect. Is it okay?
Yes, sir.
Post is known as dependent variable and group is known as fixed factor. Click on OK. The results will be in front of you. Where is my cursor?
Groups.
What is the F value in front of group?
2.202.
2.02. And this is insignificant. It means there is no effect of morning. There is no significant effect of morning walk on blood pressure. Is it okay?
Yes, sir.
We have discussed this. Now, two more important points I will discuss, and these are very essential if you want to publish articles in the reputed journals. Madam, suppose instead of this value, if the F value is 10, what you will say? Here the F value is only less than 1 or 1. We concluded that there is no significant effect. Suppose if the value is significant, means is 10, what you will say? You will say, yes, morning walk has significant effect on blood pressure. Is it okay?
Yes, sir.
If instead of 10, if this value is 100, then you will say the same. Yes, significant effect is there. Is it okay?
Yes, sir.
If this value is 1000,
Then it's significant.
significant, yes. It's surprising. On the value of 10, your results are same. Your results are same at the value of 10, 100 and 1000. No, it's not correct. You will find in Scopus indexed and Web of Science indexed or PubMed index journals, the effect size is given. You may calculate the size of the effect. What is the size of the effect? The significant effect may be of this size, small size. That may be a medium size. That may be a large size. Is it okay?
Yes, sir.
So after seeing the effect, after seeing the significant effect, or we can say that simultaneously with the effect, you should see the size of the effect also. Is it okay?
Yes, sir.
That is calculated by the eta squared value. Eta squared value. See, go to analyze, go to journal linear model, univariate, and see. This is estimates of, madam, estimates
Effect size.
of,
Effect
yes,
size.
opt for this and opt for descriptive stresses also. Continue and click on OK. See in front of the groups, the partial eta squared value is
0.075.
0.075. In this example, there is insignificant effect, so it's useless. Suppose there is a significant effect. In that case, value of 1 stands for 100%. Again, I repeat, value of 1 stands for 100%. Then in this, the value of 0.075 stands for 7.5% change in blood pressure depends on only this morning walk. Remaining 93% depends on unidentified factors. Is it okay?
Yes, sir.
So we should include partial eta squared value also in our research papers, in our researches, in our PhDs, if you conduct experimental studies. My last point. since Madam Sahu instructed me, essentially I have to complete my session. We have 12 minutes, 12, 13 minutes. You may ask questions, but one more point I would like to clear. Same as effect size, one more measure we should include our research paper. That is known as confidence interval. Confidence interval. Madam, I will ask a question from you. Suppose the madam, forecasting department conduct research on.
Yes.
Yes, forecasting department on the basis of research predicted that the tomorrow's temperature will be in between 2 to 50 degree. What you will do? You will be ready for summer clothes or winter clothes?
Summer clothes.
Madam, prediction is in between 2 degree to 50 degree, 2 degree to 50 degree. That will be useless for you, madam. That will be useless. Maybe chances of cold, maybe chances of
Summer.
summer. Is it okay?
Yes.
It means these types of researches, these types of findings are useless for us. I am trying to explain one point. Second is, suppose the forecasting department predicted that the tomorrow's temperature will be in between to 5 to 7 degree. Is it useful or useless?
Useful.
Is it useful? It means same is applicable in confidence interval. The confidence interval of the second example is only 3, and the confidence interval of the first example is 40. Is it okay?
Yes, sir.
By the help of confidence interval, we can check the quality of results. Confidence interval is the interval about that we are confident about our results. So same as effect size, essentially in our studies, especially in experimental studies or in quantitative researches, we should include this. Now, my discussion ends. You can ask any type of question. Your participants are requested to ask questions. You may write your questions in the chat box. I will reply your all answers. 10 minutes remains.
Sir, I have one question.
Yes.
Sir, suppose we have 3 trends: linear trend, quadratic trend, cubic trend, and fourth order trend.
Yes.
Sir, suppose there is a case, 3 trends are satisfying and 1 is not satisfying.
Yes.
So, sir, in this situation, what we have to do? Should we continue our research or not? Because only one observation.
Conducted as such, it means only this. Please try to understand my point. You said that linear trend is significant, quadratic trend is significant, and cubic trend is significant. Fourth order trend is not significant. Is it okay?
Yes, sir.
It means the duration up to third trend is sufficient. There is no need to give any type of treatment further. That is sufficient. Is it okay?
Yes, sir. Understood, sir.
Any other question? You may write your questions. Participants may write questions in chat box also. As per the directions of Madam Sahu, I covered with the speed. No question from participant side. Question is, for every, uh, I will read one by one. For every experiment, why can't we use a random group? It is we uh, we can't use, since if you have a limited number of subjects, in that case it will be very difficult to, mm, and it is very difficult to make a control group. Suppose you are in this hypothetical example, effect of morning on blood pressure. Suppose you have taken two groups, one is experiment control, and the control group students, they are cycling. It is very difficult to control due to this reason. Next question is, uh, Varun Dubey, what is the p-value in non-parametric test? The concept of p-value is not only related to non-parametric, that is related to parametric as well as non-parametric. The p-value means the significance value is, it is written in abbreviation. P-value means the significance value. This is known as significance value. Sir, what other software we can use? Yes, there is a long list of the softwares. Minitab is there, Statista is there, Statistica is there. It's you can download a free trial version of 1 month. This SPSS also. Does R Studio provide the same feature? I do not have an idea about the R Studio. Maybe or may not be. Maybe slight difference. We should have the concept of application of the statistical tools. All softwares fulfills the same.
Sir, if the trial period ends, 30 days trial period end, is there any student version available for this IBM SPSS
No,
software?
it's not available. It's not free of cost.
Okay, sir, how much is the pricing? Because I was searching yesterday, but I couldn't find it. So,
That depends on the number of users.
okay.
Number of users. Okay. In, Individually, it is very difficult to purchase, but I think your institution purchased this, or
Okay, okay, sir. Thank you, sir.
sir, kindly guide us about some book we can follow for studying these topics. Yes. Bhatnagarji, you are from which stream?
Sir, computer science.
Computer science. Yes, you may consult the book Business Statistics. Business Statistics by written by Ken Black, Ken. There is no need to purchase. You will find a PDF copy on the internet also, or Indian version is also there. Business Statistics written by Ken Black, Kenblack, Ken Black. Any other question?